So here we have the caller. This guy is the caller, and then this guy is the slider, right? So you have just to my pen. Okay, this is what we have, right? This guy is fixed here. This guy is fixed here, and then we have our, baby caller is here, and we have a spring, right? Side to it. Okay, and they tell us the curve, the equation for this guy is y is given to you as 8 minus x squared over 2. مظبوط? Okay, so the 5-pound caller slides on a smooth rod so that when it is at A, at this point, on A, right, it has a speed of 10 feet per second. So at A, it has that velocity. If the spring to which it is attached has a free length of 3 feet and a stiffness of K is given, determine normal force on the caller and the acceleration of the caller at that instant. All right, so we need to find the normal force on the caller, and we also need to calculate the acceleration of the caller at this instant. So Shulla, what is the number one step that you want to do? What is the first step that we have to do here? Free body diagram, exactly. We're gonna do
free body diagram.
Yep. Okay, so this is the caller, right? Okay, we're gonna draw two figures for it. So this is one, and then this is the other one. On one, we're gonna put external forces, right? External forces, and here we're gonna put inertial. Right? Inertial forces come from the word inertia. Inertia means mass, right? That's, I think, a Greek word. Maybe it's a Greek word. I'm not sure. You should check it. Okay, what is the external forces that we have to put here? شو forces?
Force in the direction of V.
لحظة. Force in the direction of V. Why? Usually, the force which is in the opposite direction of V is a friction force, right? بس هون it said it's a smooth rod, right? Keyword
okay,
is
so no
smooth
friction.
rod. Yeah. So what are the forces that are applied on the caller?
MG وتبع الرسور.
Weight and the normal.
MG. Very well. What else?
السبرينج.
The spring, exactly. So the spring is here, right? So we're gonna have force along that, right? And what is the force of the spring, by the way?
The tension.
Yeah, what is it? What is it equal to?
K times L? I don't know, I forgot. Delta L يعني.
لحظة. If you stretch it, right? If L is greater than L0, so it will be KL minus L0. ما هي K هنا they gave us the free length of the spring, right?
Yes.
3 feet, right? So K, if L is greater than L0, then this guy is going to be in tension. We're good, right? We know the angle here, ما هي K. We know this angle. مظبوط. We know 2 feet, right? And then we know Y. Can get this angle. Okay, any other forces?
The caller, no reaction.
Okay, how would that look like?
بس دكتور كيف بنعرف الانجل؟ ما فهمت. في تو ما في شيء غير.
Right, so I'm saying the angle of the spring, you should be able to tell it from here. ما هيك, so if x is equal to 2, you can calculate y. ما هيك? You can calculate y. So this is the angle that I'm talking about, right? So هيدا الانجل, we know the angle of the spring, right? Because we know this guy is 2, مش هيك? وهيدا it's y of 2, right? What is y? Y of 2. مظبوط. 8 minus 2 square over 2. 2 square over 2 is 6. مش هيك؟ So y is equal to 6. مظبوط. So هذا الانجل is alpha. What is tangent alpha equal to? 2 over 6, right? Does that make sense, guys? So here, that is the angle that the force of spring makes with the vertical line, right? And I'm able to actually capture it from here, from this diagram. I know my x-axis, my x coordinate of point A is 2. I can actually get y, right? And I think some of you are chatting. I don't see the chat, so just talk. Open up your microphones and then speak. Let your voices be heard. Okay, so what else now? What should I do? Any other forces here or no?
The reaction of the caller.
Okay, how would that?
Perpendicular to the path.
Yep, it's going to be perpendicular to the path.
It's perpendicular to the path.
This is your normal force, right? So we know the normal is going to be perpendicular to that, right? Okay, how about on here? What are the inertial forces that we have here? How can you calculate that?
MA in the direction of the path.
Yep. So we have, okay, so they gave us a velocity along that, right? So what can we get out of here?
يعني perpendicular to the normal صح؟
هون they are not giving us it's not polar coordinate. ما هيك نحن هون عندنا AT و AN مظبوط؟ You guys agree? So hone we don't have the polar, so we have AN and then AT, right? What is AN equal to? M.
V squared over R.
How can I get R?
Using the formula طبعا.
Using the formula, exactly. Do we have AT or no? We may, right? Because we have some forces here, right? Okay. We may have tangential acceleration because we actually have these guys. Okay, guys, so now it's only a matter of actually capturing these angles, right? How do you, so how can I go from here? Can someone help me out? How can I find, okay, let's begin. How can I find this angle?
We
Right
sum
here?
the forces in the direction of M.
How can I find this angle?
It's dy over dx for x equals to 2.
Yep, exactly. So this, yep, exactly. This angle is the angle between the curve and the horizontal line, right? This is a horizontal line. We said tangent beta is equal to dy over dx, right? So beta is equal to inverse tangent of dy over dx. Guys, you are expected to be solving all these assignments. It's very important. What is dy over dx? I have it from here, right? I know my y. So what is dy over dx? So I'm going to rewrite 8 minus x squared over 2, bravo, exactly. Dy over dx is equal to minus x, which makes sense. My slope is always negative. As you go from here to here, your slope is always negative, right? Okay, so what is the angle? Beta is going to be inverse tangent of dy over dx of 2, مظبوط? So it's minus 2. Can someone get us the angle?
Minus 63.43.
Bravo, thank you very much. So now we have this angle, right? So هذا angle is equal to how much? So as absolute
بس
value.
دكتور لا عم ضيع شوي ليش خدتوا دي واي اوفر دي اكس عم ضيع شوي فيهم
Yeah. So here we're finding the angle between the horizontal line and the curve, right? Now we know AT is going to be along the curve, along the movement, or along the path, right? We know the equation of the path here, right? So simply this angle is the angle between the path and the horizontal line, right? We can get that. And that is my horizontal line, right? On both ends. So this is my horizontal line. Okay, guys. So okay.
Standard يعني standard method.
Yeah, exactly. Every time, yeah, exactly. So if we need to actually, okay, what else do we need to be able to find? We need to find the n. Okay. So we might want to sum the forces along the direction of n, right? You guys agree? We know mv squared over r, correct? You guys agree?
Yes.
Okay. So now it's only a matter of basically solving the angles. All right. So what is the next step right now? How are we gonna do this? What is this angle, by the way? Can anyone tell me?
90 minus the one that we got.
Exactly. Why? Because you know this guy is al beta, right? And then I know this guy here is gonna be 90 degrees, right? Okay. Can you get that number for me? 90 minus 63.43.
26.57.
Yep. So 26. Okay. So now we have this angle. How about this angle? What is that angle here?
It's the same.
It's the same, exactly. Yup. So this angle right here is also 26 point. Okay, good. So now we're closing out on all the angles. How about this angle right here? We know this angle, right? This angle will actually be equal to 63.43, right? Right? This angle is also 63.43 because this whole thing is 90. Does that make sense?
Yes, yes.
Okay, because this whole thing is 90. How about this angle? If you look into the figure, I want to know this angle right here. How can I find this angle? We already did, right? It's alpha. ما هيك قلنا alpha, right? We said tangent alpha is opposite over adjacent. Opposite is what? Yeah. Okay.
2/6.
Okay, great. Okay. Yes. Okay, guys, one second. Okay, so yep. So we know alpha, right? Tangent alpha is 2/6. So this is 2/6, right? So we can get alpha. Did you guys understand how we got alpha? Maybe.
Yes.
Okay, great, awesome. So we have alpha. Can someone get me the number? What is alpha?
$18.43.
So it's 18.43 degrees. So this is my alpha right here. Okay, how can I find now n? So I think if I sum the forces along this direction, we can get n, but we need to know this angle right here. You guys agree? Okay, so k is actually in that direction. So we need to know this angle, right? So we know alpha, we know this guy is going to be 90, right? We know alpha. مظبوط. We know that this guy is going to be 90 degrees, so we can actually get this whole angle, right? So we can get this whole angle, right? And this angle is going to be equal to what? This whole angle minus this angle. Does it make sense or no?
This whole angle مش هو 90 minus 18.43.
هيدا كله, right? What is this whole angle?
مش 90 minus 18.43.
Exactly, yes, exactly. Because we know this angle here is going to be 90 degree, right? This guy is a right triangle, right? Okay. So this guy is going to be what? So I'm just going to come here. This angle is going to be equal to what? Okay, so I'm going to do both of them, right? So this guy, let's come here. Okay. So what is this guy? We said this guy is going to be, so 90.
71.57.
90 minus 18.43, which is going to be 63 point that, right? Which is basically equal to, yep.
71.57 تطلع.
Oh, okay. How much?
71.57.
بس دكتور ما فهمت وين ال 90 هون؟ ما عم بفهم.
What I'm saying is we need to get this whole angle, right? We're trying to sum all these forces along the normal direction, okay? So we would need to get the angles between all these forces and then this normal direction. All right. I know my angle here is going to be 18.43, which I got it from here. right? I need to get that angle right here, right? So basically, if you look into here, basically you have something like that, right? You know, this angle is 18.43. What about this angle? This angle is going to be 90 minus.
اوكي مش الحد.
So this guy is here, okay? Now we need to know this guy. What is this guy equal to? It will be 71.57 minus 26.57, right? مظبوط, right?
Yes.
Which is equal to how much?
45.
45 even?
Yes.
Okay. Okay, we're good. So now we can sum the forces along the normal direction, right? So let's do that. Okay, can you guys help me out? I'm trying to sum the forces along the normal direction, right? What is that equal to? Okay, how about let's look into the forces. What do you have?
N أول شيء N.
Okay, bravo. And yep.
وفي mg times cosine 63 point
Minus ما هيك minus mg cosine 63.43. Very well.
minus the reaction times
minus k
45
ما هيك
cosine 45.
k ما هيك L minus L0 مظبوط multiplied by what?
cosine 45
Excellent. Okay, we're good on this end. Is equal to what?
minus mv squared over r.
100% minus mv square over r. What is L by the way?
مش هنا اعطونا L minus L0
هنا اعطينا L0. L0 is equal to 3 مش هيك؟ L0 is 3 feet, right? What is L?
radical of 2 squared plus 6 squared يعني y.
Exactly. L is square root of 2 square plus plus what?
6 squared.
6 square. Okay, which is the length of the spring هلا at that is. It's very important, okay? We're good, right? We know M, we know G, we know all these guys, we know the stiffness of the spring, we know the velocity, we still need to get the radius, right? So the radius, I'm just gonna give it to you from the solution. You just apply the equation, okay? ما هيك radius is equal to what? 11.18 feet. So you just do the equation 1 plus d over the x squared divided by absolute value of the curvature or the second derivative of the curve. Is it all good? Okay, now they ask us to find the acceleration. How can you find AT? We need to find the tangential acceleration, right? How can we find the tangential acceleration?
We sum them up in this direction.
Exactly, we'll literally sum them up in that direction. نحن هلا we know this angle. Okay, which angle? So now, okay, if we sum them, we're gonna get what? The n will cancel out, ما هيك? We're gonna get only mg sine this, right? You guys agree? So this is the direction, right?
Yes. بس أذكر هون مش أحيانا نعملها إنه
It's
another
done.
angle.
لا لا, it's
نجيب هاي
easy.
الفكرة
No,
function of it.
it's done. mg sine 63.4 plus the force of spring sine 45, right?
Yes.
Okay. So hey, the times sine 45, it will give you this component, right? It will give you this component plus mg sine 30, sine 63.8, right? And I know the angle of the spring force is with respect to the normal force,
90.
right?
Yes.
Yeah. Okay. So that is this problem, okay? This is what they have here, and then this is what they have here on 45 degrees, right? So you have 45 degree, we have 26.57, maheke, and then this is 80, and then this is my 63, okay? So we're all good here. Guys, what is important to me is, what is the issue with this diagram?
إنه الفورسز والإنرشيا اثنيناتهم على ذات الوحدة.
Excellent, كتير منيح, bravo, yep, yep. The issue with the diagram and the forces and acceleration are on the same diagram. You never want to do that, okay? You don't want to do this. What I'm teaching you guys is something that you can take with you, beyond LAU, like to graduate school. You can go to, anywhere in the world, like, and then apply this and then really succeed. You know what I mean? So it's very important that you do that. And we've had students from LAU basically going to really very elite universities in the US, like MIT, Stanford, so you can definitely just apply the stuff that you are learning, and then go all the way through with it. Make sure you are solving all these assignments. Any other questions, guys? And so all these really problems are basically the same. Okay, make sure you are solving all of these problems. You guys have any specific problem that you want me to solve now, other than that? Okay, how about this problem? Okay, let's do this problem, okay? Okay, so this problem here, basically have arm rotating, and then angular velocity of the arm is 5 radian per second. Angular acceleration of the arm is 2 radian per second squared, when theta is 90. We have to find the normal force.
ثلاثة حالين مثله بالكتاب، فينا نحل هو طبعا البلوكس الاي بي سي لما يكونوا بلوكس فوق بعضهم.
Here?
No, في problem 3 بلوكس فوق بعضهم.
Yeah, هيدا the problem. I'm gonna solve it sometimes later, and then I'm gonna post it. It's gonna take some time. We only have 10 minutes left.
مسؤولين عنه للفحص ولا لا؟
This particular problem, no, not this particular problem. بس أنت مسؤول عن anything that has to do with friction, like this guy, for example. Let me actually.
Okay, واللي فوقه.
Here? Yeah, this one. Yeah, you are responsible for this problem. Let us solve this problem, okay? This
okay.
you're responsible for this type of problems. Each of the two blocks has a mass m. The coefficient of kinetic friction at all surfaces of contact is mu. If a horizontal force P moves the bottom block, determine the acceleration of the bottom block in each case. If a horizontal force P, okay, so we need to find the acceleration. Okay, let's start with the first problem on top. So this is my block, and then this is another block. Okay, can someone help me with the free body diagram on this? How does the free body diagram look like on this?
لا البلوك التحتاني لحاله.
All of them, right? We need to find the acceleration. Yeah, we need to find the acceleration of this block. Yep.
يعني mg reaction.
So عندنا mg. Yep.
والرياكشن تبعه، وفي كمان تبع الويت تبع البلوك اللي فوقه هيدا.
Yep, exactly, right. So we have another force on top. Excellent.
وفي تو فريكشن، واحدة تبع الجراوند وواحدة تبع البلوك اللي فوقه.
Okay, so what? Okay, so we have one mg on top, one mg. So this mg is actually applied here, right? So here mg is applied on this point, right? And عندنا mg at the center of gravity of the block, and another mg at the top point, right? Right? I can maybe make it bigger, okay? So just so you can see it. So we have one mg here, مظبوط. This is the weight of it, right? Then عندنا one mg here, correct? Then we have a normal force. Okay, what else do we have? And then we have P, right?
No friction.
Okay, how is the friction like?
To the right.
Okay, so we're pulling it. So head friction and head friction is equal to what? Mu mg. ما هيك؟ Mu times n لأن هون is equal to mg, right? How about here? What is the friction? What is the friction here?
Mu times n هون مش.
What is n equal to?
2 mg. يعني
exactly. If you sum the forces in a vertical direction, we know that n is equal to 2 mg, right? So the friction here is equal to 2 mu mg. Okay, we're done with this part. How about the acceleration diagram? MA, that's it, MA. Okay, so if we sum the forces, in the left direction, what do you get?
P
P
is equal to MA.
minus 3 mu
Minus
mg is equal to ma. Okay, so what is the acceleration of the block? Is going to be equal to P minus 3. Okay, guys, so that's it. Let's solve the other problem. The other one that has the pulley,
Okay,
right?
I gotta go.
Okay. We have 5 minutes left. Are you guys good, or do you guys let me? I'll just quickly solve it. Yeah, you can go. It's fine. So regarding the other part, basically we have this guy, and then we have here. Okay, and then this is a force P. Now, how does the free body diagram change on here? So as you are pulling this guy, the friction force will not change, right? And you will always have عندنا mg من هون, عندنا mg here. We have n, we have p. As a result of the sliding hone, what are we going to have?
friction.
Yep. Even if you have more friction, it doesn't actually matter. We will still actually have hone mu mg. The fact that it's sliding, whether this guy is sliding in the opposite direction or not. ما هيك هون ال sliding velocity, there is more sliding velocity than here, right? هون معنا كثير sliding velocity, but the friction will always be mu mg. It will not change, right? It will not be, if you increase the velocity, it will not be. It will later on, when you learn about damping, we'll see that damping is actually related to the velocity. Here it's not, right? So this guy will actually be equal to this. What else here? We will actually have here n is going to be equal to 2 mu mg. What else though? We actually have another thing here. We actually have a tension though. Okay? Tension in the wire. Okay? What is the tension equal to? So the tension is going all the way down, and then it's covering the other block. So what is the tension on the first block? On the first block, you are going to have a friction, which is mu mg, عنا mg وعنا n ما هيك, and then this guy is going to be equal to وعنا tension من هون, and then I'm talking about the upper block, and then this guy is MA. وبنعرف ال MA he is the same for both of them, right? So this guy is MA. This guy is a bottom block. This guy is a top block. I'm sorry, and then this guy is MA هيك. Does that make sense? So if I actually sum the forces, let me bring it here. Okay. So if I sum the forces on the top block, what do I get? I'm going to get T minus, sorry, ahead friction is in the opposite direction, right? Friction is in the opposite direction. T minus mu mg is equal to شو? MA, مظبوط? This is the top block. If you sum the forces left side on the bottom block, what do you get? You get P minus T, right? P minus T minus 3 mu mg is equal to MA, right? So we have these two equations. I can take T from here. T is going to be equal to M mu G plus A, right? T is equal to M, right? Mu G plus A, and then I'm going to take this T and then plug it here, right? So ultimately you have T P minus M mu G plus A minus 3 mu mg is equal to MA. Okay, so now we're good. We can find A. Can simplify it even more. P minus M mu G minus M A minus 3 mu mg is equal to MA. So P minus 4 mu mg is equal to 2MA. So A is equal to P minus 4 mu mg over 2M. Okay, so this is the difference. Try to solve it. Make sure you are following the same approach as I'm doing, right? It's very important you do forces on one end, acceleration on the other end. Here, T is common. The acceleration is the same in the direction of the movement. And that's it. We have about a minute left here. Any questions? You guys let me know. Other than that, I think we're good. You know, maybe we can have another session next week. If you want, prepare the problems that you want to solve. You know, except that 3-block friction problem. Don't worry about it. I'll find some time later to solve it and then post it. Other than that, I think we're good to go here.
So it's Monday on 6, right?
Yep.
Okay, you'll send us the email and we will reply by the email also.
Yep. Exactly.
Okay, thank you.
Yeah. Bye, guys. Bye. Stay
Bye
safe.
bye. Thank you.
Bye.